is we have been seeing cloud infrastructure fundamentals. Before we can move on to do stuff with data, before we can move on to do stuff with AI, we have to have our infrastructure modernized. So it's kind of like our house. Before we can do furniture for our house, our house has to be built. We can't do that before it is built. It's the same thing. So in the infrastructure part, what we are seeing is like this is the step 3 in which we have slowly seen the pieces we need to modernize in our ecosystem. And once these pieces have been modernized, that's when we are truly ready to move to the data analytics part, the big data, leveraging everything, whatever everybody has been saying. Data is the new oil, data is the new electricity, every company is a data company, all the codes like that. If you want to take use of that, we have to have stuff until now. Okay, so today it's again introduction we have had until now. It's for around 10 to 15 minutes. We'll see a bit of about containers. Then again 10 to 15 minutes, a bit introduction about big data and machine learning. So we'll have more stuff about machine learning coming up soon enough. But this is the kind of like quick introduction. So we'll have fun. We'll take a look at the fun stuff, and in after half an hour, we'll take a look at a bit of hands-on lab today in a bit more detail. Okay. So let's talk about containers. Okay. So containers is, I would like to say containers are not new, but they are. Back in 2014 when containers began. So when I was doing a QA job, at that point, my job was actually maintaining environments. Okay. So 7 environments we had. They were a lot many to handle, and ensuring that they were in sync, everything is up to date, everything is running. That was like quite difficult. When I started doing machine learning, okay, at that time, people needed at least a few days to get all the dependencies needed for machine learning. So, when somebody actually started using containers, then they realized, oh, where were you for my entire lifetime? I needed you, like I had needed nobody before. That's what happened for container. Okay, container is nothing but a place which is encapsulation, which contains everything needed for a software. Let's just say I'm running, let's say VLC, and VLC needs certain libraries. So instead of just the software, I package my libraries in a box and I give the whole box, right? So it's kind of like ordering from a pizza from, let's say, Domino's. Okay, I get it with container so that it is easy to transport and it is easy to eat from it. Nobody just brings in pizza in their hand, right? It's the same thing. My software contains the software code, the libraries it depends on. That is called as a container. So we'll see why containers is such a big deal and why we should be actually knowing that. Okay, so this is a paradigm of infrastructure as a service, which is here on the left hand side. Okay, in infrastructure as a service, we are managing everything. Okay, the other end, it is platform as a service, where the platform provider is managing everything, and somewhere down the line is a Kubernetes in the middle. Okay, this guy sits between these two extremes, and this has made a job of DevOps and the job of SRE people very easy. Okay, if let's say what what blood and sweat people from SRE are sacrificing so that you use a software without any downtime, you'll appreciate their efforts more. So for them, Kubernetes is a lifesaver. Okay, it makes stuff very easy and it makes stuff very scalable. So let's talk about containers. So if you had learned OS, you would have heard operating system is a let's say translator. It sits between hardware and software. Okay, so this app is my software and OS is my the person sitting in between. So hardware, so there is going to be drivers, there is going to be OS code. So there are a lot of code is like interacting with the hardware. OS has lots of that code, and on top of that we have OS specific code. Okay, whenever I'm using virtual machine, that paradigm which began with VMware, what happens is like I just have a hardware, and on that hardware I have multiple virtual machines running. So I could have, let's say, a Linux, a Mac, a Windows, all running on one machine, and they could be using different apps. They could be running different apps in just one machine. That was the virtualization. Okay, here in the virtualization, the problem was, okay, the OS part is like it all of the OS implement common drivers, whether it is interacting with the hardware, communicating with some kind of messages from the software, whatever it may be, it's common, right? So what if we also take that common part, put it outside, and make something out of it? Okay, that was the concept of containers. Okay, so what containers does is like, let's combine the common part and let's make it container runtime. Okay, so OS, let's say OS of 1 GB RAM. In the 1 GB RAM, let's say there is around 500 MB of RAM is allocated to common part. Okay, and that common part is implemented by every OS which is running on the virtual machine. So we take all of that into one place. So instead of, let's say that it was VM was running, there are 5 VMs running. So total 5 GB of RAM was getting consumed and 500 GB was replicated, 500 MB was replicated 5 times. Let's take that one. So what happens is like you just have a RAM and memory and code required for the application. Okay, that is a container. Okay, now comes a configuration of container with help of Kubernetes. Okay, so container is like, it's one thing, we have a container for a software, and now where is that container running? Okay, that container runs on hardware, right? Now if I'm using, let's say, Kubernetes, what happens is Kubernetes manages the containers. So let's say container is what, nothing but a box, right? Box contains the code, libraries, and it runs on something else, right? The hardware. Now with help of Kubernetes, what we can do is actually, oh, I need more computation power here. Let's just clone the container and run it somewhere else. So I have twice the computation power. If I want again more computation power, let's clone it again. Let's run it somewhere. Thrice the computation power. And this thing is done automatically by Kubernetes based on, of course, configuration files and something. And that's the knowledge we need to have. Okay. If you are new to DevOps and you are not knowing Kubernetes, then that's a bad mistake. Kubernetes going forward is going to be very important, and even until now, the stuff which has simplified, it's just mind-blowing in terms of people who have been spending their efforts in making softwares more reliable, the SRE people and DevOps people. Okay, so going forward, it's like I am not going to go into bit detail of here. Let's just think of it as a simple basic website. So on the right hand side we have code. What is the code? A simple website which is going to say a thing which all programs say in the beginning: hello world. Okay, we're going to say hello world. Okay, and that is this code, and I'm going to containerize this code. Okay, so my code is containerized and I am going to run it on Kubernetes. Okay, so you see, this is the Docker, the container stuff which it uses. So Docker container is what we use. So we have created .py server and we are running the Docker thing. So my one container now is running. Okay, now going forward, what happens? Like, what is Kubernetes going to do? Okay, Kubernetes, I'll be honest, I find it very difficult. Okay, unless everything is difficult unless you spend time doing it, right? But Kubernetes, you need to spend a bit of time to get used to what it is doing, why it is doing something, the command line part, whatever it may be. You have to spend time doing that, and once you have done that, then it gives you the advantage. Okay, so let me just tell you, just directly go to a slide which can simply explain my website. Okay, so let's say I deploy my website on Kubernetes. Okay, my website is hello world. Okay, now let's just say let's take a look at internet live stats, and let's see how many searches are happening in 1 second on few websites. So I'm going to 1 second thing and I'm scrolling down to, let's say, Google. No, not even Google. Let's go to YouTube. So on YouTube, in 1 second, so many people are Vellas apparently that 84,000 videos were seen. Okay, so we have 84,000 people who are on YouTube. So imagine traffic on YouTube. Imagine the load on YouTube. Okay, So if I want to meet that, if there is suddenly a spike, there is a, let's say, IPL video or some controversy or some interview which has come, and we want to see that. Okay, so we need to scale to that demand. We need to scale to that increased demand. Okay, that's what Kubernetes does. Okay, we deploy our website on Kubernetes by using this command, which is kind of like a simple thing. This is the final stage. I say kubectl expose my deployment on the port 80 and put a load balancer on top of it. Before that, how did it do? It's like it created simply run the image. So this was the container which was created, and we ran it on Kubernetes here. Then what comes next is running it as a deployment. So, okay, I run it. Now I expose it to the world to say, okay, you're fortunate enough to run it now, and it starts running. Okay, so if it scales for a really large number of traffic, it's still gonna automatically figure out how to increase its computational power, and that's the power. Okay, Kubernetes makes our life very easy. We can configure lots of settings for scaling, auto scaling, what's the bare minimum performance, all kinds of things. They are really amazing, they're really useful. So that's why I learned Kubernetes. It's a separate track altogether. Okay, it's going to be very useful if you get certified in that. And what are the different certification tracks we have already shared that in past 2 webinars, and we are going to do that in this webinar as well. Okay, so configuration files, how they are, how do they look like. So in the beginning, this will look like a Greek Latin to you because you have not learned it. So it's okay, right? It's okay. It becomes easy. When I started learning machine learning, it was Greek and Latin to me. It started making sense after 6 months. Same thing is going to happen for Kubernetes. It's just that I haven't done that. Okay. So you see, when we get some configurations like kubectl get pods, this returns my hardware status. Okay, so when I say my hardware status, what do I mean? Oh, which ones are running? What is their age? Is there something which is failing? If it is failing, what should I do? Where is it getting changed? All the stuff like this can be monitored with help of kubectl commands. So, in the beginning, it's gonna be complex. It's not gonna make sense. But when you spend time learning that, it will start making sense to you. Okay, so now it's kind of like that's it. That about figures it out. That is about it for Kubernetes. Like I said, it was like a crash course, a super fast crash course, wherein kind of like we just did punches of these things, bam, 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 knowledge bomb. But there is an elaborate course. It takes about 3-4 days, even just to cover basics. So don't cut this short. Don't think it is as easy. It is not easy. It's just that we are covering the broad overview here. Okay, so let's kind of like that was the kind one section. The other section is big data and machine learning. Okay, in big data and machine learning, I would like to divide that into 2 parts. First part, big data. Okay, and second part, machine learning. Okay, now unless you are living under a rock or something, machine learning is the new buzzword now. It's amazing how huge machine learning has become. It's insane. Okay, so back in 2012, when it was realized that it has potential, so people started jumping on the bandwagon. In 2015, many companies had created their own libraries by now. TensorFlow was released, a few other libraries were released, and then kind of like machine learning on a large scale became possible. Okay, so that's when this huge deluge of people has come. And in India, right, we follow the group, and that's why there is a lot of people going here. But I'm not saying that it's a bad thing. I'm saying that it is a fun thing. Machine learning, I love it. It's fun. Okay, so we are gonna see big data part and machine learning part. Why? Because big data is the reason machine learning has become possible now, because machine learning actually needed more data. So advent of cloud, advent of big data, ubiquitousness of internet, all of these things factors into the equation of machine learning. Machine learning is made possible by all these 3 things. Okay, so we'll take a look at first big data, and we'll take a look at AI platform. Before I do that, let me just show you one possible example of what machine learning could do, and it's a really fun example. Okay, so let me close this up and let me open this up. So Game of Thrones, I'm a huge fan of Game of Thrones. Okay, and the final episode, I was waiting for so long for the final fight, and fight against Night King and blah blah blah. And when I saw the episode, I was like really surprised at how dark it was. Okay, my computer was at a full brightness, but still I couldn't make sense of what was happening. After I saw the episode, I kind of like downloaded that, and then I used an editor through which I increased the brightness, increased the sharpness, and then I watched the episode. Still, it did not make sense to me. So some fan, he spent his time trying to brighten the images. So this is how it looked in the actual episode, and this is how it looked after doing the brightening. Okay, this is how it looked on the left hand side, Arya, and this is on the right hand side. This is how it looked after the brightening. The scene of Daenerys and Jon Snow, full romantic, not romantic, it's like scene full of sparks, let's just say. And if you can't see that, what's the use, right? So you see, this was the brightening thing. This is a feature kind of like present on see in the dark, which is on the pixel. See in the dark, if I search GitHub. So this is a feature, AI feature present inside Pixel Camera, which was created on GitHub as a software which is available for free. So a kind of like a image which could have come as a very dark, like in the middle or maybe on the left hand side. This is how it comes by doing this image sharpening with help of AI. Okay, how old is this? This is 2 years old. Now this tech has become, could have become much better. So if you want to see old Game of Thrones episode, or if you want to see Lord of the Rings, if you want to see any Harry Potter thing, any action scenes which are dark, okay, you could actually ideally use a software like this, which is taking the images and brightening it. How amazing is that? Okay, if I want to read a novel and I can't wait for the translation of that novel to come, if a AI system translates that novel for me, how amazing is that? So I'm a huge manga fan. Okay, I'm Japanese anime and comics. So there was a manga which I used to wait really desperately, and but this translation didn't come on time. So the translations were around 200 episodes behind the original thing. So what I used to do was I used to use OCR, convert it to text, then use translation on it, and then read the comics, then read the manga. All was done possible with help of AI. Okay, if otherwise I would have needed to learn Japanese in order to be able to read that, but I was saved from doing that. The reason is AI. So AI is amazing, AI is fun, and now let's just see the foundation of AI, which is big data. Okay, so this slide is actually more than enough for us to understand what are the big data services available on Google Cloud. I am going to mark this as a cross because we have a different alternative now. We use Jupyter Lab on Google Cloud, which is an AI platform. So let's just take a look at only these 4 products. Okay, so big data, if you know, big data entire let's say journey started with Hadoop. So everybody knows Hadoop, or at least uses a tiny bit of Hadoop thing. So many companies who are into big data, they do that. So if they want to do that on Google Cloud, use data prompts. That's it. A check mark and we're done. Okay. Now, if I want to do data processing in a scalable way, in an automatic way, I don't have to worry about, oh, I wonder where it is running. I wonder how many softwares it is using. I wonder how many machines it is using. I wonder how do I increase the capacity. If I don't want that headache, then I'll use data. So Dataproc can also do data processing, but we need to do the optimization part. We need to manage the infrastructure part. Not completely, some of that part is taken care by the cloud provider, or rather a lot of part is taken care by the cloud provider, but it is actually not completely automatic like Dataflow. In Dataflow, you just run it and it simply is done. Okay, now is BigQuery. Okay, BigQuery is amazing. BigQuery is just amazing. Okay, I'll show you. So right now, this is a time of contagion, which is coronavirus. Okay, this is not as bad as it was in 14th century. Okay, the biggest pandemic humanity has ever known has been Black Plague, a bubonic Black Plague, wherein you would get a knot in your this, and once you got a knot, then you would kind of like die in less than a week. Okay, so that bubonic plague, okay, that plague in 14th century, it caused around half the population of Europe to be wiped out. Half. You can imagine how worse it was. Okay, half the population died. It means half the population survived, right? Common sense. Now, whoever survived, okay, they survived because they had a genetic mutation which helped them survive. Okay, and that was in back in 14th century, and the descendants of those people who survived, they are still alive in Europe. You will find that genetic mutation is present in 5% of the population of Europe. That genetic mutation is called as CCR5, and that genetic mutation is still of interest to us because that not only makes people immune to plague, but it also makes them more resistant to diseases like malaria and AIDS. Okay, so imagine a gene like that, if you can synthesize protein out of, how amazing that would be. But in order to be able to do that, we need to be able to crunch the huge data we have in a very small amount of time. That is what BigQuery allows us to do. BigQuery in a second can process 500 GB of data easily, like this. BigQuery doesn't care. For BigQuery is no big deal at all. So BigQuery is just amazing in doing that. Okay, so we can do analytics like that, and right now we are at a situation where gene editing is possible. We can edit our DNA. It's just that we don't know what to edit. We don't know what to do. That's where we are actually missing. But we can edit our DNA. So let's say we find out a DNA which can. So around a few months back, around a month back, I had gone to medical store, and there was a diet pill, Himalaya diet pill. Okay, so I was like, oh, cool, interesting. Let's try it out. So let's check it out. So I took that diet pill. Okay, and in that diet pill, it had instructions. So for maximum efforts, maximum effects from this pill, eat less, drink more water, and exercise a lot. That was the prerequisite of the diet pill. If I can do that, why would I need diet pill, right? Actually, you see, this thing, there are a few people in a certain region in the world where they are actually genetically predisposed to gain muscles without even doing exercise. A friend of mine is like that. I think he has 6 packs without exercising. Okay, so if I could get that gene and put it into myself, how amazing that would be. And the foundation, the data warehouse, which could make crunching of such huge data possible, is BigQuery. Okay, remember that gene I was talking about, which made people immune to Black Plague in 14th century, which also makes them resistant to HIV and malaria? That gene is CCR5. I'm searching that gene. This Synthego company is the gene editing company which I talked about. Search. Now the entire genetic code of Homo sapiens is being searched, and we can have the result. You see, we have to have the result of whatever processing we are doing this quickly. We have to have response this quickly, and that's why we have to use BigQuery. Okay, so, and these products kind of like they constitute for a lot of work. So this is done, and PubSub is kind of like simple. If I have to do communication or synchronous communication like IoT, IoT was a big deal, and after 5G, IoT is going to become even bigger deal. Whether it is industries, whether it is farming, whether it is any kind of like thing, even healthcare. Okay, so IoT is going to become huge in less than 5 years. And who communicates that data, which is like small? But I want communication done in a really scalable manner. PubSub is the guy who communicates that. It is a synchronous messaging system. Okay, so that was kind of like this overview. So while doing that, I've actually covered all the slides. So I said data proc is nothing but managed Hadoop. We can create cluster, create and destroy cluster very easily. It can automatically grow up and down based on the configurations I've provided. It's easy to use. That's data proc. Then we have it's like the migration part. Let me not go about it. Then is the data flow. data processing pipelines, huge data. Even if the data is huge, maybe the entire GitHub data, entire Wikipedia data, lots of internet data. Spotify used this to kind of like back in 2019 when it ended. I'm sure you would have noticed that. Okay, your year in review, that video of Spotify, they were very popular. Okay, they were done by a kind of like huge data crunching of that was done by a data flow pipeline like this. So it is very scalable and it is very amazing. Okay, it looks like this UI kind of like visual thing. It's pretty nice, it's pretty interesting, and when you learn it, you'll find that this is a kind of like very interesting thing. Okay, so that was the data flow. Then we have BigQuery. I talked about BigQuery. I love BigQuery. Okay, so I would say BigQuery is my second favorite. First favorite is my machine learning. Okay, so BigQuery is just amazing. So easy to use, so fast, quite cheap, and yeah, it makes the data warehousing really fun, really fun. Okay, so PubSub was the asynchronous messaging system. It's like very simple product. Even if you simply watch a video which is less than 10 minutes, you'll understand what PubSub is. Even reading the documentation is more than enough for it. Okay, so that was the PubSub part. So that was the big data part. Now is the AI part. Okay, so for AI part, let's just see some example. So for AI part, I am going to show you. Let's see this one. So I already talked about anime. I already talked about I like animes. So there this company, its entire business statement is like provide the anime kind of like things, but in this way. You build a character and then these characters are kind of like changed so that the person who is drawing, that person won't have to spend time trying every permutation and a combination of this thing. Imagine how amazing we could make animation movies with help of this, right? If we could create realistic characters like from this in real life. So there is this thing called as generated photos. Not generated photos, let's just say another website. Here there are two images. One of them is the real person, other is a person created by AI, like this website. Whatever is generated here, this is AI in work. Here also one of the images is fake. Which one do you think is real? I think right hand side looks more real, so I'm going to select that. So I know one of them is fake, that's why I have selected one of them is more real than other. But if I had not known that, I would have definitely been very in a difficult situation to even say okay, which one of them is not real. Oh, look at this baby, and it is a baby, but I don't know, looks a bit weird. So I think left hand side is real. So I'm correct again. Right hand side. So this, and this. I think left hand side, right hand side is real. Okay. So because I have played this game a lot, I've kind of learned how to spot what is real and what is not real. Wow. Now this is difficult. This is truly difficult. I mean, wow. I don't know which one is real. I mean, this looks like too imperfect to be generated by AI, but AI can also do that. So I think this is real, but amazing. Wow, how ultra realistic this kid is, and how amazing is the AI which generated that, right? I mean, I can't find anything which is not realistic here. Just amazing, just mind blowing. So you see, example of AI. AI has made a lot of things possible, a lot of things, whether it is translation, whether it is speech to text, whether it is stuff like this. In medical industry, AI is becoming very popular. AI is kind of like helping in the COVID analysis. AI is helping lots of antibiotic creation. So previously, medical trials to create a new antibiotic used to take decades. Okay, lots of money was spent. Now it takes around only a few years. Actually rendering the whether a plane will fly or not, that used to be done using wind tunneling, wherein you actually had to put the design of the plane in a tunnel where lots of wind was sent, and we used to actually check whether it is feasible or not. Now this can be done in a model simulation which has a AI component in it. You can imagine how amazing AI is. Okay, no wonder it's so interesting. Okay, so you see, on Google Cloud, the AI platform ecosystem is very mature. Okay, TensorFlow library, which is the number one or maybe number two now. I still number one. It's still number one. So the library, which is the most popular, it was done by Google, open source by Google, still one of the heavily used. Any of the other tools also very mature, also very fun. So AI on Google Cloud is super cool. Okay, so depends on your data, what kind of data you have, it doesn't matter. You actually get a extremely amazing, let's say, power. Like in Spider-Man, with great power comes great responsibility. Here, this is the kind of like power we have. We can use it in our softwares, and we don't have to do lots of those stuff ourselves. So it's like a really amazing thing. So we have lots of APIs, which are the easiest things in Google Cloud. Okay, so Vision API detects stuff in Vision. Speech API can do speech to text. It can recognize lots of images and blah blah blah. Then we have natural language API, which is like analytics of natural language. Then we have translation. So I don't think you need to know what translation can do. It's obvious what translation does. Okay. So video intelligence can actually analyze the video. So if I have a security tape and I want to find out when somebody entered and exited, video intelligence can do that. It can detect short change. It can detect, annotation. It can do lots of things. So same as the image API will do. Okay. So that was kind of like, just quick overview of AI. I know it was not at all enough time to be able to, go into these things into more detail, but, this is not that detailed course. This is a fundamental course. And for that, we have covered quite a lot. Okay. So now the time is for the hands-on lab related stuff. Okay. So let me just skip the summary. We don't need that. Let's just talk about quick labs. Okay, so I am going to repeat these instructions one more time. Okay, let me just repeat. So quick lab is a place where you actually can run the labs and you can experiment with Google Cloud for free. Okay, you see there is a free tier account available on Google Cloud, but only very basic stuff is available for free. Let's say in terms of compute engines, very one F1 micro instance is available for free. Whereas if I'm using quick lab, even I could run big experiments without any problem. Okay, so for the quick labs thing, the link which you can follow is this link, bit.ly link. So bit.ly, and not li or l-e-e, but bit.ly. Okay, and then the link is 2 capital W, 6 capital R, 6 capital F, H. Okay, you go there, create a quick lab account, start the lab, do follow that lab, and then once you have done, this should give you after you end the kind of like a lab, this should give you a free 1 month way of executing. Otherwise, this will directly redirect you to a quest. So the quest which we are going to see, oops, the quest which we are going to see is cloud engineering quest. Okay, so cloud engineering quest is if you can do that, this will add around, this is DevJams. Okay, if you do this, it gives you 20 points. So why is points like these are important? Why do you need a flag specifying that you have completed a lab? This is just a proof. Okay, ideally we want knowledge. Okay, everywhere, any job, anything we want, everybody cares about knowledge, but knowledge is also, it can be fake. Not really, I mean, but to actually detect it in a very high accuracy, the person has to spend time actually going about it. It's not like we have a helmet which we put on our brain, like a helmet of Charles Xavier's in X-Men. It's not like if you put it there and that simply says what's your knowledge of the job. No, that doesn't happen, right? So for knowledge confirmation, we can either communicate and showcase the knowledge we have, or we can showcase it through the projects we have done, or we can showcase through the flags like these. After you do these labs and all the series which we have done, this is the final session of the series, you get a badge. That badge is your proof. It's your proof of honor that you have actually completed. And that that's just one of the components. When you combine that with your knowledge, it should be good for you. Okay, so we are going to do cloud engineering lab, and let's just see that. So the lab which I will choose for demo is SQL for BigQuery and Cloud SQL. I told you I like BigQuery. Okay, BigQuery is cool. So let me just start the lab. Okay, and how do you go here? You go through the bit.ly link, which I think will be shared with you. Don't worry about it. Okay, so I start the lab, then I log into incognito window, and in the incognito window is where I kind of like copy paste the username and password. Okay, so what's the username and password? Copy the username as is, copy the password as is. Okay, confirm. And once I have logged in and accept the all service request, then I select the project. So I'm going to select the project after this thing is finished. So let me select the project, and the project, what the project is going to be. It is Quick Labs GCP 04 AC8 something. Okay, this is the project, and I'm done. This takes care of the billing. Okay, I now have access to Google Cloud Platform, wherein I don't have to worry about the billing. This is available to me for how much time? It is available for me for 1 hour and 13 minutes now. Okay, and I should be doing just the lab here. So let's just do that. Let's just be good boys. So you see, this is the BigQuery thing, and in BigQuery thing, this BigQuery is a big data warehouse. Okay, it's big data warehouse, but even though it is big data warehouse, the data could be in GB, data could be in TB, data could be in petabyte. The query language is SQL. Okay, that's the fun part. That's why BigQuery is so easy to use. Query language is SQL. So let's just check. Let's just get the data, and let's just try to insert that data into this thing and query. So I don't know if this talks about importing, but okay, this is asking me questions. A keyword that specifies fields that you want to pull from. Okay, select. It's obvious. Wait, why can't I? Oh, okay. So select table from, and this has to be where? Okay. So BigQuery thing, this is asking me what's the BigQuery UI gonna look like. So open BigQuery. So I'm opening navigation menu here. I'm scrolling down. I'm reaching to BigQuery. After I reach BigQuery, this shows me this is the new BigQuery UI. Here in my project, there is no data set available. So here I won't be able to do the testing of queries. So let me scroll down. It is asking us to add the data, which is on the right hand side of resources. Okay. It is asking us to search London. Okay. And it is asking us London bicycle. Okay. Add data, explore public, type London. London dekha. It suddenly reminded me of what was the, I forgot what was London देखा, Paris देखा, सब देखा मेरी जान. सारे जग में कहीं नहीं है दूसरा हिंदुस्तान. I don't know which movie it is from, but I suddenly recalled this because of this data set. Anyways, so let me just view this data set. And voila. Okay, it's available for me in this, and I'm going to see where it is. Okay, London bicycles is this one. I'm going to say, let's say cycle hire, and I'm going to, let's say, select this. On the right hand side, you see I say query table, copy table, blah blah blah. I'm going to query table. I'm going to do select star, and when I simply do select star, this gives me how much data is this query going to run. Just 2.6 GB of data, very small. Okay, very small, no big deal. Let me see if the other is bigger. So I'm going to query other table. Select star. 75 KB. It's so less. I mean, it's useless. Okay, Let me find out another this thing. Wikipedia, is there Wikipedia? Okay, Wikipedia is, I know this data set is big. So Wikipedia, Wikidata, and let me check how big is this thing. So details. This is 1 TB. 1 TB is also not that big. I mean, okay, fine, but it's better than GB something. Okay. So this is the BigQuery Wikipedia thing. I have done somewhere, and let me just do select star. Okay. Why will this process 0? Okay. Let me just say remove the where thing. Okay. This query will process now 1.1 TB of data, and let me say run. Okay. So this query of running 1 TB of data, remember 1 TB hard drive, how much big data it has, and this entire data set of 1 TB was processed in 1.9 seconds, in 2 seconds. So 1 second, 500 GB. I told you, no matter what kind of big calculations you do in BigQuery can do it. BigQuery is amazing. You can write query language here, you can save it somewhere. On the right hand side, it will tell you, bottom part in green, it will tell you how much data it's going to process. If there is syntax error, it becomes red. So if I remove this, syntax error comes, and okay, it will show you. If I click on it, so I click on it, this will show you syntax error, select list must not be empty, and I simply put something here and error is fixed. Okay, that's BigQuery thing. So this was just a bit of thing, and let's just scroll down. It asked us cycle higher, and then it is asking us few queries to run. Okay, so let me just select this query and let me just run it. So run it here. This query is processing around 676 MB. Oh, it is good query to run. Previously I ran 1 TB worth of query. Right now I'm running 1 GB worth of query. But it doesn't mean it is going to be executed in less than a millisecond. Okay, BigQuery kind of like, wow, but it took 8 seconds. I'm just surprised. It shouldn't have taken 8 seconds. It still should have been maybe 4 or 5 seconds or something, because BigQuery is best for big data. Okay, if I'm querying for 1 MB, 1 GB or something, it might not be as fast. Okay, so maybe I'll go into execution details and find out why this query took average max, average max, average max. It's fine. I mean, I think this query, the way it is structured or something, for small data, you can't expect BigQuery to be fast. Right? It's optimized just for big data. So this thing is proven here. Okay. So this was that lab, going through different queries, getting understanding of what kind of different queries we have, some advanced functionalities of the SQL, which is supported by BigQuery. So group by, count, order by, where, everybody knows SQL. Okay, everybody knows SQL, and if you wanna if you wanna find out how common is SQL, you can actually see on XKCD. On XKCD, this is one of my popular things. Okay, so now I'll show you live demo of a AI thing. So this is an image I'm going to save on my machine. Okay, I'm going to this website and I'm going to upload this image there. It is a artwork. Noise reduction I want to do high. I want to do it 2x. I'm not a robot, and I'm saying convert. Okay, so this is an image, and this is the previous image. Notice a difference? This is the new image, and this is the previous image. One, it has been sharpened, but two, it has actually increased its resolution. That's AI. So this Waifu 2x, it's like AI super resolution. It's not that great yet. Even better things have been developed, AI super resolution. So you can upload a 2 megapixel image, it will give you 8 megapixel image, 10 megapixel image, which is very amazing, noise removed and everything. So you see, I was talking about SQL, this on XKCD, this joke was popular. If you don't sanitize your SQL, what happens? So this just shows you how common is SQL knowledge. And when you do this lab, you will actually understand how to do this SQL thing on BigQuery, which is a data warehouse. So it's fun. Okay. Technology is fun. I don't know why people don't have fun in technology, but for me, it is just mind blowing because there is always something more. Okay, you can truly do really interesting stuff, and this powerful stuff gives you a lot of open, publicly available data sets. Okay, if I check here in BigQuery public data, I have data of Austrian crime, Austrian accidents, baseball data, Bitcoin data, lots and lots of data. I can do lots of fun things. So that's very cool. Okay, so tech is cool. You can kind of like check it out. Please do this quest. If you do this quest, it will add around 20 points to it will like get accumulated. So it's like we have had a baseline quest. Before that we have introduction, intro quest. Now we have cloud engineering quest. Please do them. Each will kind of like accumulate a few points towards your kind of like total score. Okay, so this was the cloud engineering part. And I'll just keep this slide again for you to understand how to take advantage of that slide. Okay, and for the certifications, this is the certification path. Okay, I will just zoom a bit on each. So we have cloud infrastructure certification. In that we can kind of like go from the left hand side to right hand side. The stuff in blue and in green, it's available as courses on Coursera. Then the stuff in yellow, maybe dark yellow, we have the quick labs. When you go on the right hand side, then these are some extra resources. And when you have done all that, you are ready for these certifications. Okay, when you are certified, you have a proof of your knowledge. So certifications is good to have. Then we have application development, and for application development, we have courses like this. We have GCP Fundamentals, then we have developing apps on Google Cloud, then we have Cloud Engineering Quest, the one which we have right now. Okay, this will make you overview of the this thing, which is the application development part. So it should be very useful. Then we have Cloud Development Quest, which is much more advanced. If you want, you can do that. And once you have done the courses, you can get certified for professional cloud developer. Then is the big data and machine learning, which starts with GCP Big Data and ML Fundamentals. Then you do data engineering course, I teach that. Then you have the baseline data and ML part. Then you have data engineering quest. Then we have the practice exam, and then we get certified. So the rest G Suite ones I won't talk about. So this is your journey. If you do that, you will have proof of your knowledge, and these certifications, they have a lot of value.